Piecewise functions. I know they're not brand new to you, but we're going to kind of define what they are. So a piecewise function is a function that is defined by pieces of other functions on a sequence of intervals. Okay, so that's why it's called a piecewise. You piece other functions together. You have intervals on which you're looking at them, though. We're not looking at the whole thing. I cut and pasted this picture, and I didn't go back and edit. We do want arrows on there. This doesn't actually stop for this picture. All right, so this function here that you have, hopefully when I printed it, the grid actually showed up behind there well enough. Is this a parent function? Yes or no? Yes. Of what? Absolute value. So yes, this is absolute value. So since it is, f of x equals just the absolute value of x, right? So you can write that just as a function in itself. Can this be defined as a piecewise function? Instead of saying it's the absolute value of x, could we look at it as pieces of two other functions? What do you think? Yes? Okay. So we can. This is what we're going to do. So we're going to do that. We're going to say, all right, f of x equals, and then you have to do the little curly brackets here. How many pieces do we have? 2. Okay, and so the first one goes from negative infinity to 0, right? And so this then is a piece of what function? What would that look like? Let's do the right-hand side first. Look at this. Is this a piece of a parent function, of a different parent function? Y equals x, right? That's just y equals x? So this over here is what? Negative x. So we've got f of x equals negative x, and f of x equals x, and then we have to define the intervals for which we're looking at both of those. The negative x part we only get from negative infinity to what? 0. And then we get x from 0 to infinity. Is it easier to write it as just this? Absolutely. But sometimes we have functions that can be written as piecewise pieces of other functions put together. Okay? But not every piecewise function can be written as just a function by itself. But that's kind of a good example of just a very basic piecewise function. We're all good? All right. So now look at this one. Hopefully, again, your grid printed well enough. Can this function be defined by something other than there should be a space there. That's not a new word. Other than a piecewise function. Like, could I just say this, f of x equals this, and it not be a piecewise? What do you think? Like, we had absolute value of x. It was obvious. Is this a function that you've seen before? Or does it look like it's something that's pieced together? Just pieced together, right? So this has to be a piecewise function. I can't do anything other than a piecewise function here, so this would be a no. So we're going to write this one as a piecewise as well. And this stuff is already there for us, so we don't have to really kind of figure it out. We know what our 3 pieces are, right? We've got y equals x squared, we've got y equals 6, and we've got y equals 10 minus x. So all we really have to do is define the intervals. So this is an example of a discontinuous. I actually should have asked that as a question. Like, is this continuous or discontinuous? What is it? Discontinuous. And it's kind of obvious, right? That's not real hard to figure out. So when we do that, we have 3 pieces. We have f of x equals x squared, 6, and 10 minus x. And remember, you don't rewrite the y in there or anything. Your equals is already there. The x squared, what's the domain for x squared? Negative infinity to 2. Do I include the 2? No, I do not. All right. What's the domain for 6? Careful, 2. I know. It's easy to say the y value. It's not 6. It's 2. And it's just from 2 to 2. Doesn't go anywhere, right? And then 10 minus x goes from 2. Do I include that? No. And it goes from 2 to what? 6. Do I include that? Yes. Okay. So we good on piecewise? Yes? Am I in the way? I think my trash can's in my way. I can't move over far enough. Okay. Any questions at this point? Okay, so we have this picture, and unfortunately I have a feeling that the way I put this on here, you're going to have to look at your own picture. It actually came out pretty decent. I tried to make them bigger. I'm not going to be able to keep it on my screen, so I'm going to have to scroll. All right, so this is similar to the one that's on the front. It is a little bit different, but it's similar to it. So we're going to look at these things and come up with this stuff together. We've got this domain. So you're looking at the way you find the domain of the function is kind of the same way as when you wrote it out of the piecewise. You're just writing it differently. So we go from where? Actually, let's see. I'm going to ask some questions. I'm going to make you answer. I want the domain from long. Can you give me the domain of this function? Okay. Okay. All right. Bracket. Okay. All right. And then? Okay. Okay. Yeah. Okay. Y'all agree with that? Yes? Awesome. All right. I want the range from Yadiel. Give me the range of this function. 0 to infinity. Okay. And what goes over here? Okay. Okay. Y'all agree with that? Okay. Good deal. All right. My zeros. 0 or zeros. Jasmine. What are my zeros here? 0. Y'all agree with that? Just one? Okay. We're good. Oh, it's an ugly 0. All right, y-intercept. Zeke. 0? Yep. Now getting away with the easy ones. All right, f of 1. Annis, what's f of 1? F of 1 is 1. F of 1 is 1. No. Uh-huh. Okay. Could you do negative infinity? Oh. Yeah. Duh. You totally can. Yeah. Yeah. Absolutely. And negative infinity would be easier, right? I mean, it's a matter of opinion, but what we have isn't wrong. But yes, you totally could. I'm sorry if you've had your hand up the whole time. If I'm not paying attention, answer, holler at me. I think when she was doing that, and my brain was on, I didn't even look to see if it snapped together. But yeah, remember how we talked yesterday about if you can snap them together vertically, like if I compress it this way, if I push this down, it would snap right here, and I push that up, it's going to snap. We're good, and we can do that as, it's not a continuous function, but the domain itself is continuous. So yes, absolutely, thank you. When you would need to do that, even if it takes the whole domain, is remember if we're talking about increasing and decreasing and it breaks, then we need to definitely separate it. But yes, good question. Very good question. Anything else? And one other thing, and I want to clarify this because I hear different things from different teachers and what the expectation is and what's really official. Sometimes it's hard to find what the official correct way to do certain things is because the textbooks and other things that you look at, they're just not very clear. But y-intercepts, sometimes that's acceptable. Sometimes it needs to actually be an ordered pair, right? And so I'm going to get that clarified and see if that really matters because, like I said, I get conflicting stuff, and so I'm not going to be a stickler about that. But once we get that clarified, and I keep going back to, I'll go to Mr. Ackerman, and sometimes he'll go, well, it could be this or that. I go, I don't want the you know, the mathematical jargon. I want to know what your kids are expected to do in calculus, because that's what really matters. What does a calculus teacher, whether it's in high school or college or whatever, expect of them? You know, what do y'all consider? Because usually that's about the same. Like, even though something else might be legal, if you're taking the AP exam, you've got to do this. Well, to me, that's what's important for you. So I'll clarify things like that. Because you don't want to miss something easy like the y-intercept because you didn't put it as an ordered pair, right? All right, f of negative 2. Shelby. 4. Y'all agree with that? Yes. There's not an official like point there, but yeah, it goes through that because you can tell what it is. So f of negative 2 equals 4. All right. So this one, next one, if f of x equals negative 2, what is x? Miguel. There isn't one. Very good. Because you can always change f of x to what? Y. So when you go to y equals negative 2, does not exist. Or undefined. One of the two. Very good. All right. Is this continuous? Demi. No. Can you tell me, Demi, what kind of discontinuity it has? Do you remember your options there? Okay. You can have point, jump, or infinite. There's only 3. It's jump. Okay, that looks like there are missing points, but that point really isn't missing because one is, so it's jump, since you've got to jump. So we're just going to go ahead and write that. That's not a big focus right now, but I think the more we talk, I think that's one good thing about being repetitive about it is that you're just getting more and more practice. You get your questions answered. So if we can start repeating the discontinuity now and seeing it, I think that's going to help you down the road. Okay. So now let's look at the intervals. Okay, so increasing interval. Aaron's Kevin. The increasing interval here. Okay, so increasing means, remember we're looking at the y's, right? So if I start at negative infinity and I'm doing this, are my y values increasing? No, they're decreasing, right? They start increasing right here at what? 0. Okay, and then they increase to here, which is 1. Okay, so that first part is going to go from 0 to 1, and we include them because they're closed circles, right? Is it increasing from 1 to 2? No. Is it increasing from 2, starting at 2? Yes. 2 on to, how far? Infinity. Good. And I don't include either one of those because 2 is an open circle and you don't ever include infinity. We're good? Decreasing. Hannah, give me decreasing. 2. Okay. And is that it? Yes. Okay. Y'all agree with that? Awesome. All right. Constant. Cody. What's my constant interval? Awesome. You good with that? Okay. Positive and negative. George, give me positive intervals. Okay, negative infinity to infinity. Right. Come on. Undo. Negative infinity to infinity. Do y'all agree with that? Except for 0, right? Remember, when you're doing positive and negative, do you get to include 0? You don't get to include 0, all right? Because you're looking at the y's, and the y values are positive, but 0 isn't positive or negative. So really what we have to write is, okay, George, help me fix this. I go from negative infinity to what? To 0. Do I get to include 0? No, because it's not positive or negative, right? And then I start over at 0 and go to infinity. Because if I was able to include 0, then it would be like that first one we did where we actually could go from negative infinity to infinity, okay? So the positive and negative, you don't get to include 0 because 0 itself is neither. Does that make sense to you? I know that makes everything a little bit confusing, and that's kind of what you're asking. Does that help any? Okay. All right, negative intervals. Christy. Undefined? You all agree with that? Can we do the does not exist or undefined? Just don't ever leave it blank if it's none, because then it's just wrong. Any questions? Awesome. All right, so let's do these together. F of negative 1. So if x is negative 1, what is y? 0. Right. F of 5. Negative 7. F of 9. 1. F of negative 3. 4. I'm going through these really quickly, but y'all can do this, right? This is probably like algebra 1 stuff. F of negative 6. 2. Okay, totally handle that, yes? All right. So then, for what values of x are, it should say is. One of the reasons I redid this is because I was fixing other mistakes and then I didn't fix them all. For what values of x is at, or does, it should really say does, I guess. Does, whatever. Does f of x equal 0? Negative 1 and somewhere over here, right? Can you figure out exactly what that is based on what you know right now? No. So it's this, and I'm going to put a little question mark here. I left this on here. Another teacher made this graph, and they were trying to hit those points, and they were like, dang it, I made it where it was at 0 and 1. I said, no, that's a good talking point, is that you can't find that out based on what you know. If you had the piecewise function, you could plug in numbers and figure it out, and it's not a whole number, but you don't know what it is right now, and that's okay. Sometimes I can't figure that out and be exact. You could tell me it's close to 9, but that's about all you could do. Okay? Does that make sense? All right. For what numbers x is, or does f of x greater than 0? When is x greater than 0? F of x greater than 0. How else could I ask that question and ask the same thing? When is it positive? Like, what are my positive intervals, right? Isn't that kind of asking the same thing? Right? So same question. If you can do positive intervals, you can totally do this, right? So f of x, which means y, if you need to change it to y to make it make sense, it's y. When is y greater than 0? Well, here at, that is negative 8, right? Right. So negative 8 to what? Negative 1. Do I include the negative 1? No, because I don't get to include 0. And then I don't get to include 0, so I know it's open. I don't really know what goes here. We're going to put a little question mark. Something that's kind of close to 9, right? To 10, we know. Don't worry, your test questions and like other things like that wouldn't necessarily be question mark. Oh, shoot, yes. Thank you. Just seeing if you're paying attention. Why wouldn't it? Because at negative, when x is negative 1, y is 0. And is 0 positive? No. And that's why. And that's what you keep getting confused on, which I understand. It is a confusing thing, but that's why it isn't. I know it's a closed circle, but when you're talking about positive and negative, you don't get to include the y value, the x value when y is 0. Okay? Good question. Anything else? All right. What is the domain and range of f of x? All right, so my domain, oh wait, I'm on a different one. My domain is, look at the other picture. What do we start at? Negative 8. Do I get to include it? Yes. And then we go to 10. Do I get to include it? Yes. All right, my range. Where do I start? -7. Where do I end? 5. And make sure, because I did see this on somebody's paper earlier today, and we got it fixed, but make sure it's always the left-hand side is the smaller one, and then the right-hand side is the bigger one. Okay. So always go from the bottom up or to the left to the right. All right, so then x and y intercepts of f of x. So your x-intercepts, we've kind of already answered that. That's kind of, isn't that the same question as f? Just asked a different way, right? So it's -1, and we don't know. We're not real sure. Close to 9. What's your y-intercept? -1. All right, how often would the line y equals 2 intersect the graph? So you can just kind of think about what it is, or you can go in here and we'll go to y equals 2. First of all, is y equals 2 horizontal or vertical? Horizontal. Don't get those. You cannot afford to get those mixed up anymore. So here's my y equals 2. And it doesn't even ask me where. It just says how many times. So I drew it in. How many times did it hit the graph? 1, 2, 3. Yeah. I can't tell you exactly what those points are, but I know it's 3 times, and that's all it really asks. How often does the line y equals -9 intersect the graph? None. 0. For what values of x does f of x equal 5? -8. Is there anything else? -3. -3 is actually at 4. Yeah, I know. The boxes are tiny, but actually at 4. All right, what about -4? -2 and 7. So when f of x equals -4, right, f of x is y. So that's basically the line y equals 4. I could do that. These are the places where it intersects. So it's at 2 and 7. Does that make sense? Draw it in if you need to. 2 and 7. Questions about that? All right. Let me give you the next part. We're probably not going to do all of this necessarily. This is not your assignment. It's just some notes we're going to do together. We'll jump around on this. And on the ones that are like full sheets, and we did front and back, and they're supposed to be glued in, if you fold them in half and you just put like a line of glue across the top, yeah, exactly. I figured y'all could figure it out. I'm going to try to make sure that most of the other stuff that you get isn't like that. I just didn't have the resources to do that before you got these. All right. So let's see. We don't have time to do them all. We'll just do a couple. What is this called? Function analysis. All right. So intervals of f of x. I think your graphs are a little bit better to read than mine. But let's do the first. Let's do number 1. And I think we've got the increasing and decreasing down. I want to do the positive and negative for number 1. Okay? So when you're looking at number 1, here's your x-axis, right? Whatever hits the x-axis, when you're talking positive and negative, you do not get to include it. All right? So when I know that it's positive, starting here, okay, do I get to include this point? No. And it goes from, what is that, 1, 2, 3, 4, 5? Okay, so we go from -5, and I do not get to include it because we're talking positive and negative. And then it increases until it gets to -4. Do I get to include that? No, and that's because there's an asymptote there, right? And then it's also positive. I wrote way too big. So it's going to go over here. We're not going to do this one, though. Starts at -4, don't get to include it because of the asymptote, and then it's only positive to -3. Do not include it because there's a 0 there. Right? That's why you're not including it. Then it's negative starting where? -infinity to -5. Do I get to include it? No, because that's where it is 0, and 0 is not negative. Then I start back over being negative where? -3. Don't get to include it because I can't include 0, right? I think that's going to be the tricky part of some of this for some of y'all. And then I go all the way to infinity. Okay. All right. Let's do on the back. Well, actually, let me just ask, do we need to do any more of these? What is it of this that we've done over and over again for 3 days now that's still a little bit of a sticking point or is confusing? Any of it? I think I cleared it up today. We're good. So if you look, does it look like any of these that you see that you're thinking, ooh, if I had to do that one, I might have some questions on it? Because we got 5 minutes. If I could just hit it, I just don't want to randomly pick something that could be helpful. Do any of them look like something you want to see? Are you good? Right. All of your intervals. Here, let me say this one more time because it says it on that first thing, and maybe that's something we want to write down again. The intervals that you write, what you're writing are x values, but it's the x values that are based on what is happening with the y. So let me show you where that's written. So, if you pull out your notes from, I think, the first day, the very first day. If y'all pull out your first day notes, let me see if I can. It is, yes. And that's what it's called, function vocabulary, yes. So let me show where it says on there. So, whoops. It says it right. So we can kind of talk about it again. So when we started talking about intervals, right here, this is what I think is confusing some of you, is that all intervals are intervals of x values where the y values have that behavior. So you're asking yourself, when it says positive, when are the y's positive? And you look at that, but what you write is the x values. Does that help a little bit? So whether it's constant, increasing, decreasing, any of this stuff, you are looking at the y values and what is happening with them, but it's not the y's that you're writing down. Okay? And I can see where that's what I messed up on that first day too. I wrote down the wrong one. Like I knew what I was looking at, but I wrote down the wrong thing. So you're looking at what happens with the y's and you write it for the x's. Okay? Any other questions? No, that might be like a bonus part of it. But I'm not even sure, like some of these equations we've looked at, you wouldn't even know what they are. Like this last one that we looked at, you wouldn't even be able to because it's just something random. But no, that's not going to be something I'm going to, because we haven't reviewed over that. I can't remember if it like had it on there, like it may not even have it on there, but that might be a good bonus thing.